And one thing to get across very strongly is the fact that ozone plays absolutely no favorites in any mammalian species. It attacks all carbon-carbon double bonds. It attacks amino acids, it attacks lipids. And these reactions that occur are extremely rapid. They're on the order of 10 to the minus 9th, which is extremely fast. And what's more, they are irreversible. You can't go back. So whatever you produce in the respiratory tract, you're stuck with it. When you inhale ozone, what happens? It depends upon what part of the respiratory tract you're in. If the ozone is being taken out in the nose or the trachea, where you're conducting airways, it has to first encounter the mucus layer. And that mucus layer is containing these products that I told you about, amino acids, lipids, various things that can react. And if it reacts in that layer, then obviously it lessens the amount of ozone that can get to the underlying tissue. Now, fortunately for humans, there's a lot of material in the mucus layer for which ozone can react. On the other hand, in the alveolar region, which is lined with surfactant, there's very little substances that ozone reacts with. So it is able to get to the underlying tissue much more directly. And so you have a situation where it results in greater penetration to the alveolar tissue than it does to the higher up in the airways. And unfortunately, ozone, while it's highly reactive, it's also highly insoluble. So it ends up being carried deeper into the respiratory tract, deeper into the lungs, than other pollutants such as SO2 or NO2. Before I get into the actual description of the effects, I want to just illustrate how much is 75 parts per billion of ozone, which is the new standard. Now on this slide, I've got 100 circles, and each circle, let's assume that it contains 75 smaller circles. I would need 133,332 more slides that contain nothing but green circles in order to represent the mass of ozone that is there when you talk about 75 parts per billion. That is an extremely small amount. It illustrates how toxic ozone is. In terms of the health effects, I'm going to first talk about some of the respiratory morbidity type of effects that have been established. They vary from respiratory symptoms to lung function, airway inflammation, airway reactivity and responsiveness, and aspects of respiratory hospital admissions and emergency room visits. We can also discuss the cardiovascular morbidity and the case for mortality for ozone. So for the first one, in terms of ozone irritating airways, the symptoms that develop are a cough, a sore or scratchy throat, the inability, as indicated here, to take a deep breath. And by the way, what has been worked out is that the inability to take that deep breath is a reflex action with the effect of ozone on C fibers. And so you can't breathe in the way you want to, and you feel this pain. You have pain with deep breath and fatigue. It's a very rapid onset when you're exposed to these higher levels. And what's more, it doesn't matter whether you're an asthmatic or not, you basically get the same kind of symptoms. Now the bottom line is that exercise greatly increases ozone doses. When you exercise, you're going to get faster and deeper penetration. So obviously one of the take-home messages on the last slide is going to be, if there's an ozone pollution episode, you shouldn't be outside exercising. And there you would have a greater chance of having, even at rest, an increase in the amount of ozone being taken in. Well, I know of no studies that have specifically examined the effects of ozone at altitude. And this is, when you look at the literature, the studies are done at sea level. They're done, to a few thousand feet, some in Albuquerque and that, but nothing really where you definitively contrasted exposure, the equivalent of sea level, and exposure the equivalent of, say, 7,000 feet. There are no data out there. However, given the things that I've talked about and the way the breathing works, the effect at altitude should be no greater than the effect at sea level. And in fact, it might be less, but the Wyoming Department of Environmental Quality staff answered a question for me that I asked about in terms of the way the instruments are calibrated in that, and they are calibrated in a way that they are independent of altitude. So the bottom line is that when it measures 120 parts per billion here or 100 parts per billion, and you say, well, this might be a potential effect, it's no different than if that was occurring at sea level. So basically, you're in the same boat as everybody else. Well, what can you do if there's an air pollution episode? I define first here about the inhaled dose, that it's a product of the ozone concentration in the air, what kind of ventilation you're doing. Are you just walking around? You know, when I go up the steps, I basically double my minute ventilation. When I'm running to catch the bus, I'm at about 35 to 40. If I'm running a track meet, I'm at 65 maximal. And then the length of time that you're being exposed. All of those together combine to determine the inhaled dose. So if you're in a pollution episode, you can reduce those factors and you will reduce the dose and thereby reduce the chances of some of the potential effects that ozone can have. So you stay indoors as much as possible. If you're working outdoors, you try to work more in the morning and not be in the afternoon, because ozone levels are typically higher in the afternoon. If you're exercising outdoors, you just got to do it. Do it in the morning, and make sure you don't do it along roadways, because you're inhaling the maximum amount of PM pollution, NOx emissions, you name it. So if you're going to exercise outdoors, you exercise at a park. Okay, you don't go along the roadway. Know your body. Pay attention to the symptoms. You know, if you know your body, you can tell when you're having this pain upon inspiration or shortness of breath. So it's up to you to know what's going on in your own body. If you have children, I am applauding the fact that you, the public, your stakeholders, are getting involved up front instead of letting this go on and seeing what you need to do. I'll just leave with you the fact that, you know, Wyoming is also known as God's country, and I'm pleased to be able to get back here anytime I can.